In this next one, we have a word problem, so we need to kind of draw a picture to see what's going on first. We have a radio direction finders are placed at points A and B, so which are 3.46 miles apart on an east-west line, with A being west of B. So what this means is if we've got a line, remember east is on the right, west is on the left, we said that A is west of B, and that the distance between the two from A to B, they tell us is 3.46 miles, so we can go ahead and fill that in, 3.46 miles. That gives us an idea of at least what we're looking at to start. Now, continuing along, if we keep on reading, from A, the bearing of a certain radio transmitter is 47.7 degrees. So now we have to take into account that we're going to go from A to a radio transmitter that's 47.7 degrees from A on that kind of bearing. So let's see what we've got. Let's kind of alter and do a new picture. So altering our picture a little bit, remember that bearings come from a direction of north. So due north from A, we're going to come on an angle of 47.7 degrees. And we're going to go towards a radio transmitter. We're going to put out here somewhere, transmitter. And let's say our whole angle here is 47.7 degrees is what they told us. And notice what happens is then we end up with a triangle if we connect the distance between the transmitter back to B. And it's an oblique triangle that we're getting. Now let's keep on going. They give us one more piece of information. They say, and from B, the bearing is 302.5 degrees. So let's see how we can fill that in our picture as well. So the bearing from B to the transmitter is 302 degrees, 302.5 degrees. So again, remembering that bearings start at the north and work their way around clockwise. So what that would mean is that all the way back to going towards the transmitter, towards this line here, would be your entire 302.5 degrees. Okay, so let's redraw this triangle without all the messy bearings drawn in off to the side so that we can just look at the triangle a little bit better. So I'm going to just redraw what we have a little bit nicer. So let's redraw so we don't get confused. And what we have our point A, we have our transmitter over here, and we have our point B. And let's see, we've got to connect the transmitter and B, and it's got a bearing too that we're going to need to use. Here's north, here's north. And let's just fill in our angles. We have 47.7 degrees. And we have all the way around here is 302 degrees. 302.5 degrees. We're getting there. And let's see what else we can fill in. We also know that the distance between this A and B along the bottom was 3.46 miles. Now let's see what else we can fill in based on our picture. Now what we're going to do is I'm going to throw a little bit of a break here. Because this was an east-west line here, and this is a northwest, we do know that this whole angle makes a 90-degree angle here, which means we can figure out the other side of the angle that's inside of the triangle by taking the 90 degrees off to the side and subtracting the angle we do know that's there, that from the bearing, the 47, you can subtract the 47.7 degrees, and let's see what we end up with. We end up with an angle of 42.3 degrees. That will be what's inside of our triangle there. Let's see, we can also figure out what this part of our angle is, because we do know that if we look from the north line all the way to the west line should be 270 degrees. So we can do this off to the side. So if we take our full angle all the way around, the 302.5 degrees, and subtract, let's see, the 270 degrees, what we'll end up with is the little angle inside of the triangle again, which is going to give us 32.5 degrees. So this little angle inside of the triangle is 32.5 degrees. We're getting there. We can now find the third angle in the triangle, because what do we know about triangles? They have to add up to 180 degrees. So I can find the missing angle up at the top now. Let's see. I want to find this angle up here at the top. Well, we know that all those angles have to add up to 180 degrees in a triangle, so we can take 180 degrees for the full triangle, minus the 2 we already have, so minus the 42.3 degrees, and minus the 32.5 degrees, and let's see what we end up with for our missing angle up at the top would give us 105.2 degrees. So we've got a lot, and especially what's more important, all of our angles in the triangle, the oblique triangle, filled in. There is one more thing. We didn't talk about what we were looking for. If you go back to the original problem, what are we actually looking to find? We want to find the distance of the transmitter from A. So if we go back on our picture, that means we're looking for this side of our triangle. So let's call that X. That's the thing that we're looking for, is that side X. So let's see. Let's redraw our triangle one last time with only the triangle in mind. So I'm going to ignore everything outside of the triangle and just fill in what we know about the triangle. We've got our 105.2 degrees inside. We've got our 42.3 degrees inside here. And we've got our 32.5 degrees there. We know that the base is 3.46 miles. And the thing that we're trying to find is this side, the distance between the A. Here's our side, our angle B, and here's our transmitter. So we're going to use our law of sines because we have matching sides and angles. Well, the first matching side and angle we do have is the 105.2 and the 3.46. So we'll start off with sine of the 105.2 degrees divided by the 3.46 equals, now we want to find what? We want to find side X. And so we need to use the angle that matches up with it, the 32.5. So we'll start out with sine of 32.5. And over X. And let's see, now we can cross multiply. Multiplying the X times the sine of 105.2 degrees equals, and on the other side we'll do our other cross multiplication, which would be our 3.46 times our sine of 32.5 degrees. And now lastly, we can divide both sides by the sine of 105.2 degrees. Which will give us that x equals 3.46 times sine of 32.5 degrees divided by sine of 105.2 degrees. We'd use our calculator, and that would give us that our missing side x is 1.93, which means that the distance from A to the transmitter is 1.93 miles is that distance that we're looking for. And that's it. The next thing that we want to talk about doing is finding the area of an oblique triangle. We have 3 different formulas, but they all basically say the same thing, is that